Hi math students, I've been asked a couple questions about linear regression, and I'm going to use this data and show you this scatter plot, and then how to tell what is, if you really got the line of best fit or the equation of best fit. So let me pull, let's see, I've got to pull this one over and then move the calculator to the left. There we go. Now I can squeeze both onto the same screen. Okay, make sure your calculator's on, then go to Stat, and we're going to edit the list of numbers. Now L2 is exactly what I need. I'm trying to save time here, but L1 isn't, so I'm going to come up to L1, hit clear, and then enter. That's how you can always clear out numbers. So 0, 2, 4, 6, 8, 10, 12. And these numbers happen to line up right here. If they didn't, if I put in an extra number, when I went to go Stat, Calc, number 4 to do linear regression, it gave me a dim mismatch. Sorry, it is 11 o'clock at night. So I'm just going to quit 1 and then go back to, I'll clear that out, and go back to my Stat, edit the list, and just hit delete to get rid of the number I don't want. Okay, stat plot is second, and then y equals, and when you turn this stat plot on, just hit the enter button. This is the scatter plot using L1 and L2, which we just put in, and I always just happen to change mine to the little plus sign. Then I can go zoom, and if I come down to number 9, or just hit number 9, we'll say zoom stat, which, we're doing the stat stuff, so just number 9 there, and there's the scatter plot. So now when I go Stat, over to Calc, number 4, linear regression, I come up with the equation. Now if I want to put it on top of this line, or scatter plot, I come to y equals and type it in. 0.32x plus 24.16. Now I can go graph, it'll be there, and if I went to the table, it's right there, and I can see what the missing values are predicted to be. I can do the same thing with quadratic regression, which is right below linear regression, number 5. And I just come to y equal, say y2, put that equation in, negative 0.015 x squared plus 0.5 x plus 23.85. Now when I graph it, I'll have both of them there, and when I look at my table, I'll have my predicted values as well. If I want to turn one of those equations off, say the linear equation, I just move to the equal sign, hit enter. The equation is still there, but now if I hit graph, I don't see it, and if I go to the table, I don't see it either. So the question is, how do you know which one is a better equation? y1, the linear, or y2, the quadratic? Now, we're going to turn the diagnostics on. If you have a TI-84, it'll be in your mode. You'll have a second screen down here. I don't have an 84 on my computer, I just have an 83. So I've got to go down to catalog. I'm in alpha mode, so just come over to the A, B, C, D button, right there. Come down to diagnostics, on. I hit enter, turn them on. So now when I do stat, over to calc, number 4, linear regression, I come up with an r-squared number, which is our coefficient of determination. 95% of all the variation from the scatter plot is explained by that line, that linear equation. If I do the stat, calc, and then number 5, quadratic regression, I'll come up with an r-squared of 0.98. So 98% of the scatter is explained. Now quadratic regression will always be a little bit more accurate in terms of r-squared because of this extra piece of information. But if you can stop with 0.95, that makes it a better equation. It's just simpler, there's less busyness. So in this case, I would recommend, I'm going to turn it back on, I would recommend using the predicted values for your linear equation rather than your quadratic equation, because look what the